Okay, so let's move on to a new topic known as the slope-intercept form. Before I get there though, I want to remind you about how you graph equations using the slope and the y-intercept. So remember we spoke about before, here's an equation, let's look at number 1. Here's an equation, and in order to identify the correct slope and the correct y-intercept, the y has to be by itself, doesn't it? Well, in number 1, it is by itself. So tell me then, what would be your slope in number 1? Good, 2, because it is the coefficient of x, right? And that's where the slope is always located. Okay, so what about the y-intercept? Yeah, remember, the x is equal to 0, and when I plug in 0 for x, I end up with y equaling -1. Excellent. Okay, over here, is the y by itself? You're right, it's not. So what are we going to have to do? Yeah, we're going to first off have to move that x over. So I end up with 3y equals 3 minus x. And then what are we going to have to do? Excellent. We have to divide everything by 3. Agreed? Okay, so we divide everything by 3 in order to get that y by itself. And when we do this, we end up with y equals 1 minus 1/3 x, don't we? All right, so then, is the y by itself? Yes, it is. Am I able to find the correct slope and the correct y-intercept? Yes, I am. Awesome. So let's talk about the slope first. What would be the slope in this one? Yeah, it's the coefficient of x, right? And in this case, what's that number? It's a -1/3. Excellent. What about the y-intercept? Yes, you allow 0 for x. You plug in 0 for x. What does y end up equaling? Good, it ends up equaling 1. Okay, so let's refresh our brains on how we graph these two equations. Okay, and yes, I'm going to put them on the same graph, but the point is when you do that, you have to make certain that you label everything correctly. Got it? Label everything correctly after you put it on the graph. Make sure you label the equations is what I'm trying to say. So let's look over here at the first one. I have the point 0, -1, right? So let's plot it. By the way, quick question. Is this equation a linear equation? Some say yes, some say no, some are like, I don't remember. Remember this. What's the power on x? Good, that's a 1. What's the power on the y? Also a 1. Since both x and y have a power of 1, that means this equation is linear, which means I'm going to get a line when I graph. Agreed? All right, so here's the deal. How many points make a line? 2. In problem number 1, how many points did they give me? Just 1 point. So I need a second point, don't I? Remember from the previous lecture, slope is going to help me get to that second point. It's a set of directions to get me to the second point. So I'm going to bring the slope down here. Remember, the slope formula is a fraction, right? So how do I make the 2 a fraction? Good, 2 over 1. And in the slope formula, the 2 represented which variable? Good, the y's. The top number is the y's, the bottom number is the x's. So, from the point I already know, according to the slope, since the 2 is positive, I'm going to go up 2, because up is the positive direction for the y's. And the bottom number is a positive 1, which means I'm going to go right 1, because when I go to the right, that's the positive direction for the x's. And from this point, I could do it again. I could go up 2 and right 1. So I could actually get a third point in here if I desire. And here is the graph of your equation, y equals 2x minus 1. And this is what I mean about labeling. Good? Okay. By the way, the slope was positive, correct? My line is, when I read it from left to right, the line is going uphill, isn't it? Good, they match. Uphill lines better have a positive slope. All right, let's look at the second one. So, according to the second one, my y-intercept is 0, 1. Got it. By the way, is this a linear equation? Good, it is, because x and y both have a power of 1, which means when I graph it, I'm going to get a line. And how many points make a line? 2. All I have is 1 point, so this slope is going to help me find the second point, isn't it? Okay, so remember, the top number represents which variable? Good, that's the y, and the bottom number represents x. Because that's what the slope formula is, how the slope formula is set up. So, according to the top number, in the y direction, I'm going to go down because down is going into the negative direction. So from the point I know, I'm going down 1, and then, yes, the x's are positive, so that means I'm going to the right. How many? 3. 1, 2, and 3. So there's a second point. And I could do it again if I want. I could go down 1 and 1, 2, 3 over. And when I connect these dots, here is the equation, or here's the line that represents the equation x plus 3y equaling 3. By the way, do you notice my line is a downhill line? Yeah, because the slope is negative, I better have gotten a downhill line. Cool? Okay, hang in there. I'll be right back with some other. Okay, so remember the slope-intercept form. And if you remember from a previous lecture, I actually called it the slope Y-intercept form. And it's y equals mx plus b, correct? The reason it's called slope-intercept is because this gives me what information? Yes, it gives me the slope, which is represented by m, and it gives me the y-intercept, which is represented by 0 for x, comma, b. Remember? Okay. Now, here's the deal. We're going to use this form to actually help us write an equation of a line. So we're going to go backwards. We're used to getting this information from the equation. Well, now we're going to be given this information, and they expect us to write this equation. Got it? But in order to write the equation, you need to know the slope and you need to know the y-intercept. By the way, how do you know this is the y-intercept again? Yeah, because the x is 0. So pause the video, make sure you write that down for yourself, and then restart. Okay, so you restarted, I'm back. So here's the deal. Let's look at example number 1. I guess we should look at the directions first. The directions say write an equation of a line given the following information. So let's look at the first example. They gave us m equaling 1/2, which means they gave us the what? Yes, they gave us a slope. And they gave us this point, 0, negative 6. Now, it would be ideal if this 0, negative 6 was actually the y-intercept. Is it? Some say yes, some say no, some say I don't know. Well, go back to that last note I told you to write when I said pause the video. What did you write? Yeah, you know you have the y-intercept when x is equal to 0. Is x equaling 0 here? Yeah, it is. X is actually equal to 0, which means I have been given the slope, right? I know the slope is equal to 1/2, and I actually have the y-intercept. Now remember, the y-intercept generically is 0, comma b. So I actually have the value for b here, don't I? Yeah, it's that negative 6, because negative 6 is in the place of b. Agreed? Which means, here is the generic equation, y equals mx plus b. You told me that you have the m. What is my m? 1/2. And you also told me that we have the b, negative 6. So I guess the equation that goes with this information is y equals 1/2 minus 6. Cool? Awesome. Let's move on to example number 2. So let's see what information they gave us. They said m equals negative 4/5. Yeah, they did give us the slope, right? So good there. And then they gave me a point 0, 0. Now again, it would be ideal if that point is actually the y-intercept because it makes it very easy, like we did example number 1, to plug that in. Did they give me the y-intercept? Yeah, they did. How do you know they gave you the y-intercept? Because the x is 0. So here's the deal. The y-intercept, represented by the variable b, is going to be Yeah, that's 0, the second one, isn't it? And I know my slope is equal to a negative 4/5. So, let's see, do I have the pieces of the puzzle? Do I have all the pieces of the puzzle to fill in this generic equation? I certainly do. I can write y equals what? Good, negative 4/5 x plus 0, which would just boil down to us writing y equals negative 4/5 x. And here would be the equation of the line with that information. Cool? Awesome. Hang in there. Got a story for you. Okay, so let's look at this story. The life expectancy, called Y, for all persons born in the United States is given by this equation. And the equation reads y equals 0.18x plus 67.9. They say where x is the number of years after 1950. Okay, so they gave me a question, y equals 0.18x plus 67.9. They told me y was the life expectancy for all persons born in the United States. And they said x actually represents the number of years after 1950. Cool? Okay, so we understand what's going on. We understand what x and y represent, which is extremely important. Let's look at problem number 1. They asked us to find the life expectancy of a person born in the United States in 2020. So here's the deal. They said find the life expectancy. If we're finding the life expectancy, what are we finding? Which variable? Yeah, y, because y represents a life expectancy. So we're finding y. If we're finding y, that means we better know x, right? Okay, so finding y when x equals, so what does x represent again? The number of years after 1950. Yeah, we're in 2020, right? The person is born in 2020. 2020 is how many years after 1950? Good, 70 years. So here's the thing. Now what do I do to find y? Excellent. I just plug it in. Agreed? I plug it in. So we have y equaling 0.18 times x, which we said was 70, and then plus 67.9. Okay, got those calculators out? All right, what'd you get for y? Good, 80.5. Now, let's remember what y represents. It's the life expectancy for all persons born in the United States. So that means, according to that equation, that somebody born in 2020 is expected to live 80.5 years. That's their life expectancy. Don't set that in stone, I'm just saying, but this is what that equation says. Got it? Okay, let's look at number 2. Find and interpret the slope of the equation. Well, gratefully, the equation is in y equals mx plus b format, right? So it's easy to find the slope. What's your slope? Yeah, the slope is 0.18. And that is 0.18 over 1, isn't it? Right? Because it's a, what's the word I'm looking for? It is a fraction. Slope is a fraction. But they want me to interpret that. So here's what I want you to think about. If you were graphing, you'd go up 0.18 and write 1, right? Up 0.18 and write 1, wouldn't you? So here's the deal. What this slope is telling me is this, that a person lives 0.18 years from someone born the year before. Because it keeps going up by 0.18 years, right? So if we figured out 2021, then according to this, that person in 2021 is going to live 0.18 years longer than the person in 2020. Cool? Because it keeps going up 0.18 every year. Good? Okay. And yes, there's a part 3. Part 3 says, find and interpret the y-intercept of the equation. Well, again, gratefully, right, it's set up in the correct format. So help me out. How do I find the y-intercept? Good, we let x be 0, don't we? And when x is 0 in here, what do we get? Yeah, we get 67.9. Okay, so now think about this. If x is 0, x was the number of years after 1950. So if x is 0, that means we're in what year? 1950. So x equaling 0 implies we're in 1950. And this y-intercept, right, this 67.9, whoops, this 67 point, right, not 6 point, this 67.9 years is the life expectancy of somebody who was born in 1950. Cool? Does this make sense? Okay. You guys have fun with all this stuff, and I'll catch you on the flip side.